Okay, this is the second part of the required practical. This is now the current voltage characteristic of a bulb. So you should see that we did have the resistor. Here was a resistor, and we've just replaced where the resistor was in the circuit with a standard filament lamp or a bulb. And again, we need to measure potential difference, so I'm just going to bring in the voltmeter just to avoid confusion. So we'll put the voltmeter connected in parallel across the lamp. We've still got our ammeter, so just like last time, we need to obtain some readings of particular potential differences. We're going to go for 0, 2, 4, 6, 8, 10, and then do the negatives. And for those readings of potential difference, we take a reading of current, and then we'll plot a graph and look at the graphs afterwards. So our first reading, just like last time, is the obvious one, 0. At 0 potential difference, we have a current of 0. So if we turn the power supply on, and I'm just going to adjust up to 2 volts, a little bit more, sorry. And you might be thinking the bulb isn't lit, it's not working, but as long as we have a current flowing, there is definitely current flowing through that bulb, but there is not enough yet in order for you to see the effect in. Oh, you might just be able to see that now. It is dimly lit. So we've got about 2 volts and we have 0.74 amps, or 7.5, maybe that's just changed. Okay, so we'll now go to 4 volts. If you remember when you do this in school, they are very sensitive. It's not me taking ages. And for 4 volts we have 1.03 amps. So now 6 volts. Okay, looks 6 volts. You should now see the lamp is getting brighter as I do this. So 6 volts, we have a current of 1.29 amps. Looking for 8 volts. That lamp really is bright now. Eight volts is about 1.52 amps. And then finally 10 volts, I'm around there, we have 1.71 amps. So, okay, now just like last time, if I switch this off and then swap the connections round to change the direction of the current, so this time we should get some negative potential differences, then hopefully you'll see we can do our first reading at about minus 10 volts. We have a current of minus 1.72 amps. So it's just a matter of repeating those, which we'll do, and then we can have a look at the graph in a second.
So here's our data for the potential difference current characteristic of a light bulb. What you'll see here is that we've got a very different pattern to last time. So with a fixed resistor, if I doubled the voltage, I would double the current, but this clearly isn't true in this case. Okay, so 2 volts gives me 0.75 amps here, but 4 volts only gives me 1.03, whereas I might have been expecting 1.5. Okay, why is this happening? Well, if we look at the resistance, you can see that the resistance of the bulb is not constant like it was for the fixed resistor. The resistance is increasing. Okay, the reason the resistance is increasing is because the bulb is getting hotter, and that's making the particles vibrate, which is making it harder and harder for the electrons to get through. On the characteristic, you'll see that this means the graph is a curve. So although in this middle section here, where the wire isn't too hot, it behaves pretty much like the fixed resistor. We get a straight line. As we go off towards the sides and the bulb's starting to get very hot, instead of the current carrying on in proportion to the voltage, the graph curves and we get a flattening out of the graph as the resistance increases. Okay, if you want to do this experiment a bit more accurately, what you really should do is to leave the bulb for a while at each temperature to reach an equilibrium temperature, rather than increasing the voltage too quickly.